Welcome to the deep dive. We're super thrilled you are joining us today to unpack all of this.
Survey considerations
He sees saturation in the high seas imagery.
not contain high saturation at seabed assets because the specific zone they are surveying has absolutely no significant seabed structures.
It is just a barren plain of mud. Synthetic aperture sonar, which I understand is basically the holy grail of underwater imaging. What causes it to saturate?
Synthetic aperture sonar, or ASS, is a marvel of signal processing. Instead of relying on a massive physical sonar array, it uses the forward motion of the submarine to mathematically synthesize an artificially massive antenna.
It provides almost photographic resolution of the seafloor.
It does, however, because it is so incredibly sensitive, it has a strict dynamic range.
It's the acoustic equivalent of overexposing a camera sensor.
Exactly that. The muddy seafloor absorbs a lot of sound, so the sonar system cranks up its gain, its listening sensitivity to hear the weak echoes.
Okay, I see where this is going.
What happens when that highly sensitized sonar suddenly flies over a hard steel pipeline or a concrete wellhead?
The acoustic reflection from steel is orders of magnitude stronger than mud.
If the gain is tuned for mud, the blinding echo from the steel pipeline will saturate or clip the receiver.
The data just becomes a blown-out white smudge on the screen, completely useless for engineering inspection.
Exactly.
Can't tune the camera for a bright light when we are operating in pitch black.
It's impossible. How is a survey team supposed to optimize an incredibly complex acoustic dynamic range for steel structures when they're flying over miles and miles of featureless mud?
They can't do it empirically. They have to capture the baseline data, hand it over to Kongsberg engineers, and rely on theoretical acoustic modeling to pre-program gain reduction algorithms.
Hoping they trigger correctly the exact moment the AEV crosses a pipeline next week. It is theoretical optimization for an event.
What's fascinating here is how the absence of data is almost as problematic as bad data.